an ambitious 2,000 horsepower promise that was meant to revolutionize Japan's aerial firepower. Yet it became a nightmare of breakdowns and heartbreak. Could the Nakajima Homare engine really have changed the course of World War II? Or was it destined to fail from the start? The year is 1943. Japan's war machine is straining under immense pressure in the Pacific, desperately seeking a technological leap to counter Allied advancements. Enter the Nakajima Homare engine, an 18-cylinder radial powerhouse designed to push Japanese aircraft performance to the absolute limit. Japan's aviation circles touted it as a game-changer that would deliver unprecedented horsepower and reliability to frontline fighters and bombers alike. But as history would reveal, the Homare's rocky journey from blueprint to battlefield told a very different tale, one of inflated hopes, frantic engineering, and crushing disappointment. Today, we uncover the shocking truth behind the Nakajima Homare engine, how it was meant to be Japan's ultimate secret weapon, but became emblematic of the nation's broader wartime struggles. By the end of this video, you'll see why this engine stands out not just as a mechanical marvel with extraordinary potential, but also as a cautionary story of what happens when design goals and battlefield realities collide. If you love uncovering forgotten aviation history, make sure to subscribe right now so you never miss a story like this. Let's dive straight into the tale of the Homare and see why an engine that promised so much ended up delivering so little. The origins of the Nakajima Homare engine date back to the early 1940s, a period when Japan's aviation industry was racing to keep up with American and British engine outputs. At this time, Nakajima Aircraft Company had already produced several radial engines, including the Sakaya series that powered the famous Mitsubishi A6M0. But as Allied fighters grew stronger and faster, especially in the Pacific theater, Japan realized that incremental improvements to older engine designs would no longer suffice. They needed something radical, something that could deliver raw horsepower above 1,800 or even 2,000, numbers that were rarely, if ever, reached by Japanese radials at that time. The design team, helmed by some of Japan's most experienced aviation engineers, set out to create a double-row 18-cylinder radial engine, officially designated the Nakajima HA-45 but widely known as the Homare. It aimed to deliver roughly 2,000 horsepower right out of the gate and to keep up with the likes of the American Pratt and Whitney R2800 Double Wasp and the British Bristol Centaurus. The ambition was nothing short of colossal, an engine that could power a wide range of frontline aircraft, from nimble interceptors to versatile torpedo bombers. But the challenges were equally monumental. Japan was increasingly short on high-grade materials, with key metals being rationed or simply unobtainable due to Allied blockades and disrupted supply lines. Engineers were forced to improvise, using less than ideal alloys for pistons, crankshafts, and cylinder heads. Additionally, the Homare introduced advanced features, like more complex supercharging and high compression ratios, that demanded extremely precise tolerances. In a best-case scenario, such precision is expensive and difficult to achieve. In wartime Japan, amid frantic mass production demands and resource scarcity, it verged on impossible. From its earliest days, the Homare's development was hampered by a classic wartime catch-22. The urgent need to get an engine on the front lines meant there was little time to troubleshoot each glitch. This hurry led to an engine that was conceptually impressive but rife with mechanical kinks. Ultimately, the very traits that made the Homare so enticing on paper, high horsepower and advanced features, also made it a prime candidate for engineering nightmares once it met the brutal reality of mass production, inexperienced assembly workers, and frontline maintenance shortages. We cover stories like this every week: rare aircraft, overlooked prototypes, and untold aviation histories. So if you're enjoying this deep dive, consider hitting that subscribe button right now to stay in the loop. Despite its later reputation for unreliability, the Nakajima Homare was no mere paper tiger. Its specs, at least in theory, were formidable. An 18-cylinder radial design arranged in 2 rows of 9 cylinders each gave it the volumetric capacity to deliver upwards of 2,000 horsepower when properly tuned. Early prototypes showed tremendous promise on test stands, sometimes exceeding 2,000 horsepower under ideal conditions. This was a significant leap forward for Japanese engine technology. One key innovation was its compact overall diameter for an engine in its power class. Radial engines with many cylinders often grew so large in girth that aerodynamic drag became a major concern, limiting the top speed of the aircraft they powered. Nakajima's engineers cleverly designed the Homare to remain relatively slim for its horsepower range, reducing drag when installed on fighter planes like the Nakajima Ki-84 Hayata, Allied reporting named Frank. In a perfect world, the Homare would have delivered both raw power and a sleek profile, a winning combination for building agile, high-performance fighters. Another notable feature was the engine's attempt at high-octane compatibility, theoretically allowing the use of better fuel. If high-quality fuel was available in large quantities, the Homara's performance might have further climbed above the 2,000 horsepower mark. However, Japan's late-war logistical nightmares meant that the fuel actually available at airfields was frequently of poor grade, sometimes even blended with all manner of questionable substitutes. Consequently, the Homara's advanced demands for fuel purity went largely unmet, setting it up for detonation issues, fouled spark plugs, and more frequent maintenance overhauls. Then there was the ambition of combining multiple speed superchargers. If done effectively, this could have granted outstanding high-altitude performance. In practice, the complexities of mass-producing these superchargers under wartime conditions, combined with the strategic shortage of metals, often led to subpar performance at altitude and increased mechanical failures. Even so, these engineering aspirations underscore the Homara's place in history. It wasn't simply a mediocre engine from the start. Rather, it was a bold, modern design that, had it been granted top-tier resources, more development time, and better production conditions, might have rivaled some of the best Allied radials. Unfortunately, the reality of total war rarely allows for such ideal circumstances. Despite the Homara's teething problems, the Imperial Japanese Army and Navy were in dire need of more powerful engines. As a result, the Homara found its way into multiple aircraft. It powered the Nakajima Ki-84 Hayata Frank, a fast, maneuverable Army fighter that could theoretically challenge advanced American planes like the P-51 Mustang and P-47 Thunderbolt at medium altitudes. Some variants of the Kawanishi N1KJ Shiden and N1K2J Shiden Kai, originally designed around the Mitsubishi Mk4 engine, incorporated the Homara in certain prototypes. The Shiden line itself was a formidable Navy fighter when the engine worked. The Nakajima C6N Saiun Mert, a high-speed reconnaissance plane, was tasked with outrunning enemy fighters and relied on the Homara for crucial speed. The Yokosuka P-1Y Ginga Francis, a high-speed twin-engine Navy bomber, demanded reliable, high-output engines to survive Allied interceptions. It too depended on the Homara. Finally, the Aichi B-7A Ryusei Grace, a carrier-capable torpedo dive bomber requiring strong takeoff thrust and respectable mid-altitude performance, also used it. Pilots initially reported enthusiasm for the Homara's potential. In test flights or short engagements, its top performance numbers were indeed remarkable. Some Ki-84 pilots even claimed they could outrun or outclimb certain Allied planes under the right conditions. However, these bursts of performance often came at the price of engines overheating, leaks, or sudden power drops. Maintenance crews struggled daily. They faced inadequate spare parts, poor quality lubricants, and insufficient specialized training needed to service such an advanced power plant. Simple tasks like changing spark plugs or adjusting valve clearances could become a nightmare if the parts supply chain dried up. More complex tasks, like a full engine overhaul, were close to impossible in forward operating bases with limited infrastructure. The net result was that many Homara-equipped aircraft never reached their theoretical peak performance in real-world missions. Even when the engine ran smoothly, it required such meticulous care that it was effectively a diva of the Japanese arsenal. Powerful on a good day, temperamental on most others, and in the harsh environments of the Pacific War, temperamental could be a death sentence. By the time the Homara-powered aircraft entered combat in larger numbers, the strategic tide had already turned against Japan. Allied forces had begun adopting advanced fighters such as the F-6F Hellcat, F-4U Corsair, P-51 Mustang, and P-47 Thunderbolt, while also gaining advantages in pilot training, tactics, radar-guided intercepts, and sheer numbers. In the face of these overwhelming factors, the Homara's mechanical fragility only added to Japan's woes. Pilots recount stories of engines seizing mid-flight, massive oil leaks that coated windshields in a matter of minutes, or sputtering performance at higher altitudes where the Homara's supercharger setup simply failed to deliver. The disparity between advertised horsepower and real-world reliability became all too clear. Veteran Japanese pilots who were accustomed to more predictable engines found the Homara a gamble. For every glorious mission where it delivered stellar speed or climb performance, there was another where it undercut the chances of returning home safely. Moreover, the logistics of engine replacements and repairs became an unending headache. Each forward base had to keep extra Homara units and components on hand, but shipping these from Japanese factories, often targets for B-29 bombers, was a logistical puzzle with no easy solutions. And once engines or parts did arrive, the stress of repeated emergency landings and desperate missions often meant that the Homara-powered planes were pushed far beyond their recommended operating limits. Allied forces also capitalized on captured examples and intelligence. American and British technical teams examining downed Ki-84s or C-6Ns found that the Homare was, on paper, an impressive design that simply hadn't been given the robust manufacturing environment necessary for success. Captured documents revealed severe production problems, including substandard metals used in key stress-bearing areas, poorly calibrated fuel systems, and rushed, sometimes inconsistent assembly lines. Ultimately, this engine failure represented a broader issue in Japan's late-war production. A mismatch between high design aspirations and the grim reality of a nation under siege, where industrial output was strangled, resources were limited, and many skilled technicians were either drafted or overworked to exhaustion. To grasp the Homare's strategic importance, one must compare it against rival engines of the era. The Pratt & Whitney R2800 Double Wasp, for instance, powered iconic planes like the F-4U Corsair and P-47 Thunderbolt. It matched or exceeded 2,000 horsepower reliably, backed by America's industrial muscle. Meanwhile, the Rolls-Royce Merlin, though a liquid-cooled engine, achieved legendary reliability and strong output in Spitfires and Mustangs, and Allied pilots rarely had to fear unexpected mechanical failure. Germany's Daimler-Benz DB605 was another liquid-cooled design, well known for powering Messerschmitt Bf109 variants. Although not without issues, it was produced in large numbers, and Germany's industrial base still offered more stable materials in the early to mid-years. In contrast, the Nakajima Homare aimed to propel Japan's leading warplanes into parity with these formidable foes. While it occasionally succeeded in achieving raw performance close to Allied engines, its reliability gap was a crippling weakness. In a prolonged air war, especially by 1944 and 45, when dogfights were frequent and supply lines were constantly threatened, an engine that couldn't be counted on spelled disaster. Even the best pilot and the best airframe is helpless if their engine decides to quit halfway through a mission. One can argue that the Homare represented Japan's final push toward achieving engine parity at a time when the entire strategic situation was collapsing. Had it appeared in 1942 with stable reliability, it might have reshaped key battles by giving the Imperial Japanese Army Air Service, IJAAS, and Imperial Japanese Navy Air Service, IJNAS, a much stronger aerial edge. But by the time the Homare was rolling off production lines in meaningful numbers, the unstoppable might of American industrial output and Allied strategic bombing campaigns had already sealed the fate of Japan's aviation efforts. Now, here's the moment that truly underscores the Homare's paradoxical legacy. Toward the closing months of the war, desperate Japanese strategists considered fitting the Homare to even more experimental fighters and specialized attack planes. Some historians believe it was part of a final gamble to develop miracle interceptors to knock down high-flying B-29 superfortresses and slow the Allied advance. Japanese aeronautical engineers envisioned advanced turbo supercharger variants to the Homare, theoretically pushing performance above 2,200 horsepower, enough to climb rapidly to bomber altitudes and strike Allied raids before they could devastate Japanese cities. But in a twist of tragic irony, those advanced Homare projects were barely off the drawing board when Tokyo and other major industrial centers suffered punishing firebombings. Factories that produced critical Homare components were destroyed. Specialized tooling was lost, and even the flow of raw materials like aluminum was all but choked off. Far from saving Japan, the Homare's final variants never left the prototype stage in significant numbers. The dream of a super Homare was extinguished by the same war conditions that had inspired its creation in the first place. It's a stark reminder of how advanced technology alone doesn't win wars. Production capability, logistics, and reliable performance are equally essential. The Homare had all the makings of a top-tier radial engine on paper, but circumstances doomed it to remain a half-realized legend. By the time the war ended, Allied forces systematically uncovered broken pieces of these ambitious engine projects and ruined factories and test labs. So close to the promise of raw power, yet so far from the stability needed to change the outcome of the war. The Nakajima Homare engine stands as both a testament to human ingenuity under extreme pressures and a cautionary tale about the limits of pushing advanced technology into production without the solid foundation of resources and logistics. It reminds us that in warfare, promise alone can't fill the gap left by shortages in materials, worker expertise, and systematic training. While the Homare could produce bursts of astonishing power, its legacy became one of dashed hopes and mechanical breakdowns, reflecting the dire state of Japan's war efforts in the final years. In today's world where speed and innovation still reign supreme, the story of the Homare underscores a timeless truth. Great designs require equally great support systems to truly shine. Without robust manufacturing, dependable supply chains, and the luxury of time to refine a complex product, even the most brilliant concept can become a liability. Subscribe for more deep dives into aviation legends you won't find anywhere else. Our channel is all about keeping these stories alive, stories of brilliant engineering, high stakes, and the underdog machines that might have changed history under different circumstances. Thank you for joining us on this exploration of the Nakajima Homare. May its story remind us of the bold aspirations and harsh realities that shaped history's great aerial battles. If you enjoy well-researched aviation history, hit that subscribe button before you go. And until next time, fly safe and keep the passage for vintage warbirds alive.